this isn't your first day of class. It's not your first day of class. If it was, I would.
Why do Fridays always have to be weird?
All right, quiet, please. Here we go.
Oh, I found it.
Winter, close the door, please. Hey, yesterday was a worksheet. It had all the answers on it. It was a review of everything for volume. I had a couple people ask me questions, but not many. I'm going to collect that here in a second, but I'm just going to warn you. Right, we're on the home stretch now. We got to do 2 sections on surface area, and then 1 section on spheres, both volume and surface area. I don't know why they split up volume. It's a whole special thing. They can. None of these formulas from now on for the rest of the chapter are friendly. They are ugly formulas, and they're a mess. Right. The way you get through them is you pay attention. You understand what to place inside the formula. Landon, outside. You write the formulas down, you understand what to do with them, and then you do the calculation. If I show you the formula and there's something you do not understand, then you ask questions. All right, here we go. And like I said, these are not going to be friendly forms. They're not that bad, but they are bad enough. That's going to be what we're doing right now, 9.7a, 9.7b. It's just surface area. 9.8 is going to be the spheres. We'll have 2 days of review. Please don't forget your calculators. I do not write these tests for doing it by hand. I write them knowing that you're going to have a calculator in your hand. All right, it is a worksheet. I'll hand it out at the end of class. All right, let me take care of this and we'll get going. Okay. So, ugly formulas. We're going to start off a little strange. I didn't hang up the things. No, I put them on my desk. Sorry. All right, Nate, you want to hand these out for me? This starts off, I don't know if you've ever done this before, but there's something in math called nets. Okay, a net. A net is when you take a 3-dimensional shape. We've been dealing with 3-dimensional shapes. And you think about just the skin of the shape. So in other words, just the outside. So if I think about just the outside, nothing to do with the inside, we take all the outside shapes and we lay them flat. You think about a map is a net of a sphere. Okay? You take the skin of the earth, you lay it flat, you're like, well, how do we get a rectangle for the earth? Yeah, okay, that's a portion of the net. But this is this idea of net. So a net is a 2-dimensional pattern. It's going to be a shape that you can draw on a piece of paper that you can in turn fold to make it back into the original object. That just seems weird, but that is the actual definition. Here's the common sense one. If I take the skin of this triangular prism right here and I lay it flat on the board, that's what's called the net. It's a 2-dimensional pattern that you can fold back up and make the 3-dimensional shape. You probably have seen this in arts and crafts or something before where they give you something, you cut it out with scissors, and then you fold it and it makes a 3D shape. Yeah. That's called a net. Today, we're going to be doing this thing called surface area. Surface area has to deal with just the skin of a 3D object. I'm saying skin isn't a math term. It's the outside. All right, if I took a pyramid and I thought about just the outside of the pyramid and I laid it flat on the board, I would get that shape right there. Because what the definition claims is that if you fold this, it turns back into a pyramid. Can you see how if I folded this, it would make the pyramid? Okay. That is called a net. Nate, I'll let you copy down the definition in a second. So box 1B, I want you to draw me what you think the net of a rectangular prism would look like. Draw what you think the net of this shape is. In other words, if I took the skin off of this, the outside, and I laid it flat, what would it look like? Give it a shot. I don't have that good of eyes. I definitely don't have. I can't even tell you how old enough a piece of paper. There's my mom back there waving. Oh, we're making funny jokes. All right. So if instead, and I'll show you what one looks like, and this is one of many, there are many different nets for a rectangular prism. Here's one of them. If I think about the back of this, and I draw it, there it is. Right? So if I take the red portion, see, and I drew it, it would look like this. Okay? Well, that's the back. Attached to the back are my two sides right here, and they're both what? So I got to attach those. I also have the top and the bottom. I got to attach those. And there's my two sides. But wait a minute. There's one more. Which side did I leave off? Oh, top's right here. I got the top, bottom, back. I left off the front.
So you add it to the top.
So where would it go?
Add it to the top.
I could add it here. I could add it to the bottom because the front touches the bottom, it touches the top, but it also touches the two sides. You just attach it where you think it goes. I attached it right there. Big deal. Okay. That is not the only net of a rectangular prism, but that's a net. Great. Is anybody confused on this idea of making a net? No, you're not going to be doing this tonight for homework. Right? All right. I wasn't expecting that. All right. This one's harder. See if you can draw this one.
Okay, so
This is a triangular prism. Box 2A, triangular prism. See if you can draw the net of that one. How many triangles? Count them.
oh, got it. Oh,
Grayson thinks he has it.
it's easy.
You think you got it, Anna?
No, it isn't. Never mind.
If I follow that same procedure, and there's no special thing about drawing the back first, but if I draw the back of this shape, the back is this one's a square, that one looks more like a rectangle. So if I make the back first, you don't have to always make the back first. Well, what's attached to the back?
Triangles on either side.
The triangles will be attached to the top and the bottom. Do you see that? Okay. The left and the right are also
Two sides.
rectangles, right? But the top and the bottom were triangles and, well, how many sides? One,
Oh, yeah, I
two, three,
figured it
4, 5. 1, 2, 3, 4, 5. You got it.
Okay, I just did a triangle and then I put
Net of a triangular prism.
Easy.
Once again, it's not that you're going to be doing this tonight for homework, but this concept. Listen, please. Jaden. This concept of you can turn a three-dimensional shape into well, at least the surface of it, into a two-dimensional shape is what we will be using. All right. So now if instead I start with a triangular prism that has measurements, hey, what we've been seeing the last couple of days, and I make that net, I can fill that sucker full of all the measurements. Let's see.
Hey, it's a bird.
The back has a side length of 12, sorry. There's my 12. This right rectangle has a length of 15 and 4, 15 and 4. You see what I did? I just put all the numbers there. Today, what we're going to be doing, look at me, is we're going to be figuring out the surface area. The surface area, literally, as by the name implies, is what you can touch on the surface. Well, here's everything that's on the surface. So in order to calculate the surface area of this shape, you ready? You got to have the area of all of this. It's not a really nice calculation.
It's actually not that hard. If you figure out the
There is 1, 2, 3, 4, 5 things that you got to have the area for all added together. Jaden, I am really tired. Stop. Not when you're looking behind you. Okay. All right, back up here. All we're going to do is calculate the area of each one of those shapes and add together. Or maybe, if we're lucky, we can see a pattern. Maybe we can make our lives a little bit, not much, a little bit easier. So when I show you these formulas, just so that you know it, what's really going on, You take a 3D shape, you make a net, and you add up the area of all these sides, 2 triangles, 3 rectangles. Now, there is a formula. The formula is not very memorable. I almost said memorable. But it is a formula. And if you have it written on your resource card, life is good. All right, write this down, 2B. Surface area, by definition, is the sum of the areas of a net. So it's a net, right? It's a 2D shape that can be folded back in to make the 3D shape. So we're going to be calculating surface area. In other words, we're going to take the area of all of these nets, add them up. Net is made up of all those individual pieces parts. Man, if it needs all these numbers, we got big problems because this would take forever to do it. Okay, area of shape 1 plus shape 2 plus shape 3 plus shape 4 plus shape 5, that will take a long time. There will be a formula, but it comes from this net. Yeah. Well, are all the rectangles the same shape? Sometimes yes, sometimes no. So it's not that we can just multiply one rectangle times 3. Okay. Sometimes it can be. The one that right here, all of these rectangles, these are actually squares, as someone has told me every single day. You could multiply this one, but that's because this one is made of squares. But if it was made of rectangles, no. All right. So box 3A, pause for a moment. I will show you the formula. You ready? What's the shape? Here is its net. Now here's the magic. Without the formula, you'd have to do area of this, plus 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 area of that. You'd have to do 6 calculations, and each calculation requires you to do the area of those individual pieces parts. Formula allows us to do it a little bit quickly. So stay with me. Don't let me say anything that causes you like you lost me there. If that's the case, you stop me. Here we go. SA, we're going to say, stands for surface area. So the surface area equals all those pieces added together, but we can make our life easier. Here's the idea. What do you see there in red? It's one big rectangle. So instead of adding this piece, I'm pointing to the rectangles, e-learner, this piece plus this piece plus this piece plus this piece, if we could somehow calculate or figure out the measurements of this big red rectangle, now we're only calculating one rectangle. That's a whole lot easier than 1, 2, 3, 4. So where is that rectangle on the shape? Where is the red rectangle on the shape? It would be what part of this? The skinny part. How about the middle? It would be these 4 rectangles all put together. One of the first calculations we did, and my hand is going around the circle for a reason, one of the first calculations we did on squares and rectangles was perimeter. So it turns out from here, all the way over to here is what? It's the perimeter. We're going to call this long skinny part the lateral area. Lateral means sides. So if we did the side areas, okay, it's a rectangle, so that's length times width. And if we added the bases together, the base area, this is what the formula is in the book. Not very helpful. It simply says lateral area plus base area. Now I'm going to give you the formula that makes your life a little bit easier. A little bit. Okay. We know that the lateral area of the red one is a rectangle. Rectangle is length times width, but where do we find that L and W on the red rectangle? It's not listed right here. L would be from here to here. That would be, this whole thing is your L, that would be the perimeter of either the bottom or the top. So the perimeter would be that piece, plus that piece, plus that piece, plus that piece. If you stretched all of those out, it would make that length right there. If that's the length, what's the width? Well, the width is literally the width, so that part doesn't change. So basically what we're saying is, and this is the one that we're going to write down, just pause for a second, is the perimeter of the base, that's this red square or red rectangle I just drew, times the height of the prism, Because the height of the prism ends up being this width of this red rectangle. Can you see that? It's an ugly formula. So it's the perimeter of the base times the height of the prism plus the base area. Well, the base area consists of the top and the bottom. What are the top and the bottoms on this one?
16 and 5
I don't mean, I mean just in general. What's the shape of the top and the bottom?
rectangle.
Another rectangle. And what's the formula for rectangle? Length times width. So to that, we need to add 2 of the length and the width, but we called that one the length and the width as well too. So it's the 2 of the base areas, right? Write that one down. Box 3A. That's the formula. Box, what? Oh, nice for her. This one's not on its surface area. Oh, it does have that. Well, guess what it says? Perimeter times the height times 2 of the bases. That's what I have right here. The base is a rectangle. The base area will be length times width times 2 because there's a top and a bottom. Yes. I'm sorry? I'm going to have it on every single slide. Yes. Okay. Not a friendly formula because it requires you to understand what it's asking you to do. So we better do a couple of these. All right. Hey, rectangular prism, yes? We're claiming that's the formula. If you have a Miss Garland sheet right here, it says perimeter times height times 2B, where B stands for base area. That's correct. I just think that kids are going to forget what the B stands for. All right, so let's say what we need. We need the perimeter of the base. The base is the top or the bottom. Hey, what's the perimeter of the top? Where are you getting that from?
It's the area.
Not the area, it's the perimeter. Well, the perimeter will be 4 plus 4, which is 8, plus, which is
14.
which are 11.
No, but I'm saying 14.
I got that, but that's not where I'm going. I said 4 plus 4 plus 3 plus another 3 is 14. I wasn't arguing the answer wasn't 14, but kids didn't understand where I was getting that from. So the perimeter is 14. 4 plus 4 plus 3 plus 3. That's the perimeter of the base. You're like, why did you use the top, not the bottom? I could have used the bottom. There's just no numbers written on the bottom, so I'm going where the numbers are. It says times the height of the prism. How tall is that prism? Okay. And it says 2 lengths times width. Well, the length and width are 3 and 4. So 2 times the length, which is 3. You're like, well, that's the width. Okay, whatever. Times the width, which is 4. If you want to argue I've messed up my length and width, I see what your point is. That in blue right there are all the numbers. Okay, with a calculator, it's no big deal. That's 140. 6 times 4 is 24. So it's 140 plus 24, 164. Why isn't it cubed?
Because it's not volume.
Why isn't it just centimeters?
Because it's area.
Because it's area, surface area. That's why it's squared. Okay. All right. Not a memorable. If there's a formula that you forget, it'll be this one. You will forget this. It's got to be on your resource card. All right. Big stuff. Let's do box 4 together. Here we go. Box 4. What do you want to be your base? Top, bottom, left, right, front, or back? Sides. All right. We'll use the sides as your bases. Okay. So that means that's a base. The left side's the base. That's the top and the bottom. Okay. There's my formula. I need perimeter of the base. So I need the perimeter around. Oh, it's a square. Look, 4 and 4. So I need the perimeter. What's the perimeter of this square?
16.
What? Yeah. Where are you getting 16 from?
4. 32.
No, I'm doing a teacher thing.
Oh, so
Where are you getting 16?
4 plus 4 plus 4 plus 4.
That's where we're getting 16 from.
4 times 4.
Yeah, don't go there. Don't go there because that's area. But yeah, I like the 4 plus 4 plus 4 plus 4, 16. So the perimeter is 16.
I need 28.
You get 28.
Hold on. Because guess what Mr. C used as his base?
Oh,
Okay.
okay.
All right, so I'll show you my calculation to show that we all get the same answer. So let's use yours. Unfortunately, e-learners can't see this now. We said that our perimeter was 16. What's the height of the prism now? It's 10, because you chose that as your base. So now the height is 10, plus 2 times the length and the width. Well, the length and the width are, so 4 times 4. And if you wanted to write 16, I got you. Okay, now we just do that math. That's going to give me 160. 2 times 4 times 4. 8 times 2. Sorry, 8 times 4. Sorry, 32. So what's 32 and 160? 192. 3 plus 6 is 9, not 8.
Are you sure this is the most ugliest one we've got?
Oh, the next one's even uglier. All right. So we got 192. If you chose the top and the bottom, 10 plus 10 plus 4 plus 4, that's 28. We will still get to that magic number, which was 192. You got to ask a full question.
How did you get 192?
Because you typed in the wrong numbers.
How? I didn't. I put all the right numbers.
You got multiplication symbols. 16 times 10 times 2 times 3 times 4. There's no 2 up here.
Oh,
There's no 3 up here.
Oh,
There is a 2 because the 2 is right here, but there's no, it's 4 times 4. All right, we good? All right, is that a friendly calculation or an ugly calculation? Boy, is that one ugly. All right, the way that you're successful with this, Hannah, is on test day, what happens? Hannah. I can't hear you. A calculator and a resource card. It's over 20 formulas on one test, right? You're not going to remember the 20 formulas. Please don't forget your resource card, right? By the way, you get to make your own resource card. Okay. Questions on the calculation? Oh, that's 1 of 2. We still even got another one we got to do. Questions? All right. Box number 5. Let's go. What's the shape? Rectangular prism. So remember, the basic idea is we got rectangle. Oh, this one doesn't look like that one, but rectangular prism. If we look at the surface of it, we flatten it out, and then that gives us the net. We calculate the area of that net. That's what we're doing. But that is a tough thing to do when there's 6 sides, which is why we have a formula to make our lives just a little bit easier. All right, formula. Everybody got it written down?
Yeah.
What do we want? Top, bottom, left, right, front, back is the
Top.
top? Okay. I don't know if that's what I chose, but we'll see. What's the perimeter at the top? 3 plus 3, 6. 2 plus 2, 4. 6 plus 4 is a 10. I didn't know we were going to have a visitor, otherwise I would have somebody. I didn't get the email. All right, 10. Hey, what's the height of the prism? What's the length and the width?
2 and 3.
2 and 3. You're like, well, what's this other two? The other 2 comes from the fact that what we're really doing is we're calculating the area at the top and the bottom. That's our base area. So we need 2 of one of these rectangles. Yeah.
Where did you get the other 2 at?
I literally just said that.
You did not.
Do you want me to play the video? I said, oh, for those you wondering where the 2 comes from, there's a top and the bottom. That's the base area. Right.
Okay, I'm sorry.
All right.
You don't
Well,
get this answer.
sometimes. All right, here we go. So what you get for a final answer?
82.
82. Is that what you guys got? That's 70. 2 times 2 is 4 plus 3 is 12. That is 82. Nate,
82.
how did I get 10?
82.
We need the perimeter of the base. You guys said let's use the top as we could have chose front, back, whatever. You chose the top as being the base. 2 plus 2 is, and 3 plus 3 is, because we're doing the perimeter of the base. So that's where we got 10 from. So yes, Kai can now be happy he got 2 answers.
Let's go. I got wrong.
All right. I said there were 2 of them. Here comes the other one. You ready?
No.
All right.
Wait, hold on.
Look at the board. We're going to write the formula down. In box, what are we on? 3B. So this is going to be the form for surface area of a triangular prism. Hey, once again, what's the middle? What's the shape? It's a rectangle. It's 3 rectangles. Okay. Stay with me. Okay. It's going to be the same part of the calculation. If you think about the middle and I were to unfold the 3 rectangles, you'd make one big rectangle. Therefore, I still need this dimension, and this dimension is going to be the perimeter. So I'm still going to need this length. That length is going to be the perimeter. I still need the distance between that would be this right here. I still need the distance between the 2 triangles. That's going to be, well, your width. Oh, by the way, your book says lateral area plus base area. Not a very helpful formula. This is the formula.
Oh my God.
It's still going to be the perimeter of the base. Hey, the perimeter of the base is a triangle. So we're going to do the perimeter of the triangle. That's this distance right here. Times the height of the prism. That's the distance between the 2 triangles. Times 2 of the bases. Now, the base of a triangular prism is a triangle. So I need 2 triangles. Oh, by the way, life is easier. Watch this. What's 2 times a half? So it cancels. So it's just base times height of the triangle. In yellow, write that one down. That is the formula for surface area of a triangular prism. The surface area of a triangular prism, perimeter of the base is the triangle, times the height of the prism, that's the distance between the 2 triangles, times base height. Yeah, because it's 2 of the triangles, and 2 of the triangles would equal basically a rectangle. And that's base times height.
Out of the 2, which one's easier, the triangle or the
Yes.
So with the P and H, would it be the triangle?
It's going to be the perimeter of the triangle.
Okay.
And if you instead you want to, because the base is a triangle, if you want to put perimeter of the triangle, that'd be helpful.
Okay.
These are not memorable. Everybody forget. Myself, I got to review this every time I teach it. I'm like, oh wait, make sure I don't mess this up. Well, we need both the top and the bottom. No, that's the base area. But there are 2 triangles. The form for area of a triangle is 1/2 base times height. What's 2 times a half? It cancels, which is why you're just left with BH. Okay. And these are ugly. All right. Here we go. Surface area. Well, surface area says that I need to take the perimeter of the triangle, Winter said. So we got to do the perimeter of the triangle. Sometimes you got to hunt around to find all the dimensions. Look, hey, this one's got a lot of the dimensions, but it doesn't have these 2 sides, but the back one does. It's equilateral triangle, 4, 4, and 4. So the perimeter of the triangle is what? It's 12. Where's he getting 12 from? 4 plus 4 plus 4 is 12. What's the distance between the 2 triangles? That's the height. What's the distance between the 2 triangles? It's 8. You're like, well, that's not the height. That's the height of the prism, not the height of the triangle. It says height of the prism, not height of the triangle. So I got 12 is the perimeter of the triangle. I got the height of the prism is 8. What are you doing? Times the base and the height of the triangle. The base is 4 and the height is
5.
You're supposed to ask questions if you're lost.
I couldn't contract with you.
I know. That's why I told him to stop.
Okay, so what you have to find?
I need the base and the height of the triangle.
Okay, and then
8 is the distance between the 2 triangles.
it's technically the same thing.
Wait, where did you get 12 out?
Yeah, how do
I need the perimeter of the base. What's the shape of the base?
Rectangle.
It is not. It's a
Trapezoid.
where
Parallelogram.
What?
No, there's 4 sides, so it's either a rectangle.
what's the name of the shape?
That's the triangle.
It's not a triangle. What's the name of the shape?
Oh, triangle or prism.
And the base is what shape?
Triangle.
That's why it's 12.
But that's not triangle.
Do you see the green?
Oh my God, bro.
No, I'm talking.
Do you see the green?
Yeah,
What's the
Look at me. It doesn't, it's that, I don't change the shape simply because I tip it over. It's still the same shape.
I think you
The
see
base,
that.
hold on. The base is not the bottom. It can be the bottom, not in this, not for this shape.
Well, yeah, because the four is connected to the.
Well, that's really
But like,
weird. Where, how do you get 12 from 4
How long
and
is-
5?
I have no idea what you're asking. Where's
So-
a 45?
No, 4 and 5. How do you get 12 from 4 and 5?
What's that say?
4.
It says all the sides are 4.
Yeah.
What's 4 plus 4 plus 4?
So how did you get 3?
What?
What's the shape?
Dude,
Triangle.
How many sides?
3.
4 plus 4 plus 4 is 12.
Oh.
That took way too long.
I'm sorry.
All right, back up here. That's 96, that's 20, 20 and 96, 116. Hey, I'm okay with you asking the question. If you're lost, he's not gonna be lost now, but if you're lost, you need to be asking the questions. What part?
So, just like be clear, so the first numbers from the triangles and the last number. From the triangles.
That's the smart thing right there.
And
she-
then the second one is from
The only number that isn't part of the triangle is the height of the prism.
Okay.
And that's the distance between the two triangles. But she's perfectly right. The base of the perimeter distance is from the triangle, absolutely, and base is height from triangle, absolutely. All right, let's do one box 6. Box 6. All right, there's our formula. Jackie just said, wait, the perimeter is just the perimeter of the triangle, yes. So, Landon, what's the perimeter of that triangle?
So it's 12.
It is not 12.
How did you get 11?
Why don't you look at the shape and then figure it out?
Kai, it's 11. It's 11.
How?
Look at the shape and
You
tell me,
said
look at the shape, stop talking and tell me the side measurements.
4,
That's 1,
3.
4,
that's 2.
4.
Where do you see a third 4?
Oh, 3. You said it's 4 from the last one.
It's not the same problem.
Wait,
Look at the
technically-
board.
Okay.
Find the 3 sides of the triangle.
4, 4, 4.
Where do you see a 4?
Right there.
Where do you see a 4?
Right there.
4, 4, 3.
How?
Right
How did
there.
you get 3? I understand it's right
The
there.
3 is the bottom.
You said last time. I
It's
swear
a
you did.
different problem.
But if you go
It
back,
looks
if you go
different.
back,
It says
It's
4.
oh,
Oh my God.
It's not the same problem. It's a different problem.
oh, dang.
Oh my God.
All right.
So you had a 4
You guys, if you guys ever become police officers, we are doomed.
Saving the
Because
world.
the clues are right in front of them and they don't see them. All right.
No.
All right, back up here. Let's do the calculation. So yes, everyone else determined that the perimeter was 11. The distance between the two triangles is how much? And then Jackie said, wait, we get the base and the height from the triangle, we do. The base is 3 and the height is 6.
What?
Base and the height from the triangle, look for the little square, base and height.
Any second.
Now it's just a matter of doing the calculation. That's 110, that's 18, 110 and 18 is 128. Remember, the units will be squared because we're doing surface area. When you get to test day, because we're doing all the stuff occasionally, you can forget, and oh wait, I was doing area, it's to the second power, not the third power. Or I'm doing perimeter for the simple ones, it's not squared or cubed. All right, we did, go ahead, Jackie.
So, it's like, what if, like, when we're on the test, we play with the numbers wrong, but like, we like do it right? We just take off like all the points for it. It's like partial.
Well, there is always coincidence. Like if the answer is 18 and you just happen to get 18 as an answer, but you use the wrong formula and the wrong numbers, yeah, that whole thing's wrong.
Like, if you use like the right formula, but you.
Yeah, and that's usually the more common mistake is you write the right formula, you plug the right numbers in, and then something goes wrong with your finger and your calculator and you don't get the answer. So you will at least get some credit for doing, hey, you've identified the right shape, you plugged in the right numbers. You certainly won't get the question completely right, as opposed to the person who shows up test day and says, the answer is 120, right? Well, they're close, but they didn't show me they knew what the shape was. They didn't show me what the formula was. They didn't show me what the numbers in there. I don't give them any credit for that one. So make sure, and we talked about this before, 3 steps. I need the formula, I need the numbers in, I need the calculation. All right, is this the last one?
No.
Well, there's one where I gave you a combination. All right, this is the last triangle one. The issue with this is, once again, sometimes the shape can start flipping around because it's drawn in 2 dimensions, but it's a 3 dimension. If that's the case, you take a highlighter or something like that, and you just outline the triangle so that you can see just the triangle. If I do that, there's a chance that we can calculate the perimeter. Hey, I can see that this side is 5. I can see that this side is 4. This one's not listed, but Smalley, it is.
Oh, it's 12.
This side right here is
12.
3. So that's how it can kind of, now we got to add those up. 5 plus 4 is 9, plus 3 is 12. For those that were yelling 12 at me. Sometimes it's hard to see the 2 triangles. As my eyeball, as I look at it, I got a triangle in the front, I got a triangle in the back. So the distance between them would be right here, which is not listed, but up here it says it's 3. So the height of that prism would be 3. Jackie said we go back to our triangle for the base and height. We look for the little square. The base is 4, the height is 3.
Wait, so
48?
just to make
36
sure,
and 12 is 48.
just to make sure, you added up 3, 3, and 3, right?
No.
We
Perimeter of the triangle. All right. Did I collect your homework or not?
All
right.
Tuesday.
I will not collect your homework. That way you can keep it with you.
Oh.
Have a good 3-day weekend. I'll see you guys. For those who actually did the other 2, here are the 2 answers.
Worksheet. Worksheet.
Why do I have that picture?
Because it's a butt
This is
kicker.
the one that will kick your butt.
Worksheet.
Thank you for the cupcake.
Shut.
Oh my god, okay. Dude, you think he's nicer.
No worksheet.
I gotta hand it to you.
Oh, okay.